Welcome to This Explainer. Today, we're taking a fresh look at the absolute foundational architecture of the devices we literally use every single day. Now, even if you already consider yourself pretty tech-savvy, pausing to examine the elegant fundamentals of computing is just incredibly insightful. We're going to strip away all those complex interfaces and the endless apps to uncover the beautiful, logical machine working right beneath the surface. So, let's jump right in. Here is our roadmap for today. First, we'll meet your new computer. Second, how do computers work? Third, essential parts and hardware. Fourth, hardware versus software. Fifth, why we use computers. And sixth, essential lingo and summary. Section 1. Meet your new computer. What exactly is this magic box? Before we even look at the definition, I want you to do something for me. Just look right at the screen or device you're using to watch this explainer. Whether it's a smartphone in the palm of your hand, a really sleek tablet, or a massive multi-monitor desktop setup, you are actively interacting with the exact machine we're about to decode. It often feels like magic, right? But by definition, a computer is simply an electronic device that takes in data, processes it, and outputs results. That's it. At its absolute core, stripped of all the fancy glowing lights, the high-def displays, and the infinite web pages, a computer is ultimately just a machine that strictly follows instructions. It doesn't have a mind of its own. It obediently takes whatever specific input you give it, runs the mathematical operations you told it to run, and hands you back an exact answer. The real brilliance isn't in the machine's intelligence. It's in its sheer obedience and its unmatched speed. Section 2. How do computers work? The 4 basic steps. Okay, let's dive into this. Because honestly, once you understand the mechanics of how the machine actually operates, all that mystery completely vanishes. Every single task a computer performs basically boils down to 4 fundamental steps: input, processing, output, and storage. To really grasp the logic here, think of it kind of like baking a cake. Step 1 is input. This is where you gather up your raw ingredients. You're handing the kitchen the flour, the sugar, and the eggs. Step 2 is processing. You mix those ingredients together and toss them in the oven. The oven is actively transforming those raw materials based on the exact recipe you gave it. Step 3 is output. Ding! The timer goes off, and you present this beautifully finished, fully baked cake. That's your result. And finally, step 4 is storage. You're probably not going to eat the entire cake right this second, so you put the leftovers in the fridge to keep them safe and accessible for later. Input, process, output, storage. Whether you're typing a single letter into a search bar or rendering a massive 3D movie, it always follows this exact same sequence. Section 3. Essential parts and hardware. The physical pieces. So now that we've got the processing sequence down, we need to look at the physical building blocks that actually make this input, processing, and output cycle possible in our digital kitchen. And what's really fascinating is how perfectly these specific physical parts line up with the 4 steps of our baking analogy. First up, we've got the keyboard and the mouse. These are your primary input devices. This is exactly how you hand the raw ingredients over to the computer, whether that's by typing text, moving a cursor around, or just clicking a button. Next is the CPU, which stands for Central Processing Unit. This is the brain of the whole operation, or the oven in our culinary analogy. It does all the heavy lifting, executing billions of calculations every single second to mix your data. Then we have our output devices: the monitor that shows you the visual result, the speakers that pump out the sound, and the printer that gives you a physical copy of your work. They're essentially just serving up that finished cake, presenting the processed data in a format that you, the human, can actually understand and use. Section 4. Hardware versus software, the tangibles and intangibles. Understanding this next concept is usually a huge aha moment for anyone wrapping their head around technology. So the crucial point here is grasping the contrast between hardware and software. Hardware refers to the physical components of the computer that you can actually touch and feel. The monitor, the keyboard, the CPU, basically if you can drop it on your foot and it hurts, it's hardware. On the flip side, software represents the invisible, intangible instructions and programs that tell the hardware exactly what to do. You literally cannot physically touch software. Going back to our kitchen, software is the recipe itself, the written instructions that tell the oven how hot to get and for how long. Without software, your highly advanced hardware is just an incredibly expensive, heavy paperweight. But without hardware, your software is just a theoretical idea with absolutely no way to execute in the physical world. Together, it's this beautiful, symbiotic relationship between the tangible and the intangible that creates the entire modern computing ecosystem. Let's just hit pause for a second. We've covered the foundational definitions, the 4-step process, the physical hardware, and the invisible software. But you might be wondering, so what can we actually do with all this technology? Beyond the elegant mechanics of it all, why have we gone through the immense trouble of engineering these highly complex input and output machines in the first place? Section 5. Why we use computers.
computers in the real world.
Let's transition from the mechanical how to the practical why, bringing the focus right back to your everyday life. The true power of computers really lies in their staggering versatility across virtually every single sector of human life. Consider education. We aren't just talking about typing out essays anymore. We're talking about students having instantaneous access to the entirety of human knowledge or simulating complex physics experiments directly from a laptop. In business, it's all about deep logistics. Global enterprises deploy these algorithms to track massive supply chains, optimizing inventory across the world in real time so they never run out of stock. For communication, the hardware and software work together to completely erase physical distance, compressing audio and video data so we can collaborate with colleagues halfway across the globe without even a microsecond of lag. In banking, processing power ensures high-level encryption, allowing billions of dollars to securely flow across international borders digitally, fundamentally bypassing the need for physical cash altogether. For entertainment, computers render entirely new digital realities, streaming massive cinematic files to our screens seamlessly. And in healthcare, it is quite literally a matter of life and death. Doctors rely on computers to run incredibly complex diagnostic imaging and cross-reference millions of medical records in a split second to identify precise life-saving treatments. And this brilliantly illustrates why computers have completely redefined human capability. They simply give us the ultimate advantage. First, they execute tasks incredibly fast, turning computations that would literally take a human an entire lifetime into mere milliseconds of work. Second, they're highly accurate. A machine doesn't get tired, it doesn't zone out, and it definitely doesn't make basic math errors. And third, they make managing incredibly complex systems fundamentally easier. Mastering this tool, or honestly, even just developing a deep appreciation for the underlying basics we're discussing today, is completely worth your time because it allows you to leverage these unprecedented efficiencies in your very own life and work. Section 6. Essential Lingo and Summary. Wrapping it all up. Well, we've covered a lot of vital ground today. Let's move to a quick review and see how this all builds together by synthesizing everything we've explored. First, the computer. You now know this isn't magic, it is simply a device that processes data. Next, input and output. Input is your way of talking to the machine, feeding it those raw materials, while output is the machine's way of talking back, presenting you with the finished result. Storage is exactly what it sounds like, your digital refrigerator for preserving that data long term. We talked about the CPU, the central processing unit, acting as the heavy-lifting brain or the oven of the entire operation. And finally, we drew a hard line between hardware, the physical, tangible equipment you can stub your toe on, and software, the invisible, highly structured set of instructions making the whole shebang run. You've successfully decoded the machine sitting right in front of you. You understand its physical components, its logical four-step process, and the immense global power that architecture holds. By stripping away all the complexity, the true elegance of computing really reveals itself. So I'll leave you with this one final provocative thought to ponder. Now that you know exactly how they work and the absolute infinite possibilities they offer, what will you create with yours? Thank you so much for joining me in this explainer. I really hope this deep dive has sparked your curiosity to keep exploring.